Now we're going to divide complex numbers. Okay. For that I have 71. Oh, so sorry, I moved this. I have 71 up to 73. I have those three problems to do right now, and probably I'm going to do one more, a different type of problem. So let's take 71. Alright, I have 3 over 5 plus I. When I'm dividing complex numbers, which is that what I have right now, I'm not allowed to have an imaginary on the denominator. Okay, I cannot have an imaginary number on the denominator. Because of that, I'm going to do what is called the complex conjugate. The complex conjugate is basically taking this same expression, plus 5 plus I, but changing the sign. 5 plus I now is going to be 5 minus I. Okay, and I'm going to multiply those two. Let me do it again. So the complex conjugate, and let me write it down. Complex conjugate, okay, is basically taking the same expression but changing the sign. I have 5 plus I, now it's going to be 5 minus I. In order for me to not change the expression overall, whatever I have to do on the bottom, I have to do on the top. Okay? Why? Because 5 minus I over 5, oh my god, over 5 minus I is equal to 1. Anything divided by the same thing is going to be equal to 1. So technically here I'm multiplying by 1, which I'm not changing the expression. Okay? Let me erase all these things. Alright. So I said it was a complex conjugate, and now basically at the end I'm not supposed to have an imaginary on the denominator. There will be no imaginary number at the denominator. What do I do now? Multiply. You multiply the top with the top and the bottom with the bottom. Let's do the top first. Numerators. So let's do 3 times 5 is going to give me 15. 3 times negative I is negative 3I. Okay, now let's do the bottom. How do we do the bottom? FOIL, or distributive property, or any other number name that you know. But the process is the same. You take the first one times the first one. Then you take the first one again times the second term. So 5 times negative I is negative 5I. I just used the 5 already, so now it's turn for the I. I times 5. Positive 5I. I times negative I. Negative I to the second power. Okay? I have that. Following step. What's my following step? I know I'm going to bring those over here. Let me bring the top. Can I combine 15 minus 3I? Hopefully you say no. I cannot. So I have 15 minus 3I. On the bottom, I combine whatever I can. I have negative. This is a negative, not a division there. So I hope you didn't get confused. So I need to combine like terms if I can. I have the 25. Can't combine it with anything else, so stays 25. I have I and I. I have negative 5I plus 5I. Negative 5I plus 5I, 0I, and they will cancel out. Last thing that I have is that negative I squared. Negative I squared. I squared equals negative 1. Make sure you remember that. So instead of the I squared, I'm going to write negative 1. Okay? Let's continue. So I have this. Let's keep going here to the right. The top, nothing that I can do, stays the same. 15 minus 3I. The bottom, I have 25. Negative and negative turns into positive. So I have plus 1. 15 minus 3i, 25 plus 1, 26. As you can see, there's no i's on the bottom, and that's my goal. That's why I multiply times the complex conjugate. Alright, remember, you need to change one sign. Alright, so I already proved that I'm not going to get any i's on the bottom, but still we're not done. If you remember from before or not, a complex number is written as the form of a plus bi. Right now you have a whole fraction with the I on the top. You need to break that into two fractions. This 26 is going to divide the 15, and that 26 is going to divide the negative 3i. So let's break that up into two fractions. 15 over 26 minus 3 over 26i. And that will be your answer. If there's anything you can reduce, you reduce. If like 15 can be reduced with the 26, you do it. If the 3 can be reduced with the 26, you do it. If not, that will be your final answer. 15 over 26 minus 3 over 26i. And I have my I at the end, like they want. A plus bi. That's the way they want it. This is called the standard form of a complex number. Okay, so I said that I was going to do, I don't know if a couple more or not, but basically this is the same process with 72, 73. What I'm going to do is I'm going to show you what is the complex conjugate for each one of them, and then I show you a different type of problem. So 72, 2i over 4 minus I. I'm going to do this one. 72, 2i over 4 minus I. Right? Can I have this I in the denominator? No. So that means I need to multiply times the conjugate. What's the conjugate? What's the conjugate? Is this same thing, right? Is the same thing, but with opposite sign. So it's positive. If I do it on the bottom, I have to do it on the top, so it doesn't change. So as your that's your complex conjugate. Now you do FOIL. FOIL. You know what? Let's solve this one. How do we do FOIL? The 2i multiplies the 4 is going to give you 8i. The 2i is going to multiply the I. Is going to give you 2i squared, and we'll take care of that I squared in a minute. Let's go to the bottom. Should we finish the top? You know what? Let's finish the top. Let's finish the top. Let's keep going with the top. So now I have 8i, okay, plus 2 that multiplies I squared. But what's I squared? It's negative 1. Negative 1. So that means I'm going to have 8i. Positive 2 times negative 1 is negative 2. Right? Now, so I get ready for the end. I'm not able to have an I in the beginning. So I'm going to flip those two. Negative 2 plus 8i. I'm just organizing. Okay, I'm just organizing these two. I brought the 8 to the end, and I brought the negative 2 to the beginning. That's all what I did, nothing else. Okay, so the top is done. Now let's go back to the bottom. Let's do FOIL. Let's do with green. You know what? Let's try to change. Let's change this. Let's see orange. What's gonna happen? No, you know what? Green. Okay, so let's do 4 times 4. I'm writing here underneath 16. 4 times I. 4i. Now I'll go with the negative I. Negative I times 4. Negative 4i. Negative I times I. Negative I squared. Excuse me. Okay, again, we're staying on the bottom. Let's combine whatever we can. Now I'm going to have 4i minus 4i, and they will cancel. Whenever I do the conjugate right over here, whenever I do this conjugate, the reason I do that is because I know that my i's are going to cancel. My i's will cancel, which it happens right now. 4i minus 4i will cancel down. Now I have minus I squared. Instead of the I squared, I write negative 1. That's right. Very good job. You said negative 1. It's kind of difficult for me to know you did or not, but I hope you did. So let's continue down here. I have my 16. Negative and negative. Positive. So 16 plus 1. Right? Those two equals 17. And I'm almost done. What's your last step? Break that fraction into 2. Remember, this 17 divides the negative 2, and that 17 divides the 8i. So I'm going to have negative 2 over 17 plus 18 over 17i. And that's your answer. Again, if you can you reduce that, you reduce it. If not, leave it like that, and that's fine. I will do one more. The last one that I'm going to solve is actually taking it from the textbook for my students. It's number 58. I'm sorry, from page 278, and it's negative 5 minus 3i over 4i. And the reason that I'm doing this one is because it's different. If you notice, the one that we had before, it had two terms on the bottom. I have 4 and the I, 4 minus I. Right now, I only have 4i, only one term. So, what do you do if you see something like that? Again, think always like the conjugate. Two choices. If you're used to change the sign on the bottom, then change the sign on the bottom. Then multiply times negative 4i. Whatever you do on the bottom, you do on the top. Remember. Okay? Whatever you do on the bottom, you do on the top. So, it's going to give you... Oh my god. Alright. So, if you have 4 in the bottom, you multiply times negative 4i. Do you have to multiply times negative 4i? No. You can multiply times 4i or negative 4i in this case. But again, if you want to keep your thinking that you need to change the sign, it's fine. It doesn't matter. It's not going to affect the problem itself. Now, once I have this, I do FOIL. I do distributive property on the top. Actually, not even FOIL. Just distributive property. That's all I have to do. So, on the top, I need to multiply that negative 5 minus 3i times negative 4. So it's going to be negative 4i times 5. I'm sorry, negative 4i times negative 5. 20i. And negative 4i times negative 3i. Negative 4 times negative 3 is positive 12. I times I squared. Okay? And that will be the top. The bottom, you'll have 4i times negative 4i. 4 times negative 4 is negative 16. I times I is I squared, and it's only one term. Done. We're doing great. Now it's time to change those I squares. So I have 20i on the top plus 12. Now instead of the I squared, I change it into negative 1. The bottom, I have negative 16. But instead of writing I squared, I write negative 1. Okay, you always change your your I squares to negative 1. So, keep going. I have 20i on the top and then I have that 12 times negative 1 is going to give me negative 12. On the bottom, I have negative 16 times negative 1, and that's equal to positive 16. Alright. Okay, so now remember, I want to write my numbers as a plus bi, a plus bi, which means the I has to be at the end. Do I have the I at the end? No. So I need to write it at the end. So basically from the top, what I'm going to do is, I'm going to flip that negative 12 goes on the front, and this 20i goes to the back over 16. To finish, remember, break the negative 12 over 16 and the 20 over 16 and my beautiful I at the end. So technically, you're done. Can we reduce? Yes, we can. So then we reduce. Remember, you try to divide by 2, by 3, by 4, by any common term that you can divide both numbers. Here, I can divide by 4, I can divide by 4. So, negative 12 divided by 4 is negative 3. 16 divided by 4 is 4. Okay, now, between the 20 and the 16, I can divide also by 4. So, 20 divided by 4 is 5. 16 divided by 4 is 4. And this will be my final answer. You'll have negative 3 over 4 plus 5 over 4i. And that's your answer. Done with division. Review, please. Thank you.